So now we've seen how to implement a simple decorator to support our JSON responses. Now it's time to look at one that it's a little bit more advanced. One of the topics that we haven't considered before is the topic of returning large collections. Imagine that eventually our API will grow and we are going to have a large number of customers in it. So a client requesting the /customer/ URL will have to get a really long list, and that will be unexpected. The normal thing to do in those cases where collections can be really large is to return a page and then provide information to the client to get a next page or a previous page. So now we are going to check out version 0.12 of our application. And now we have a new decorator here that will give us pagination support for our collections. Before I show you the decorator, let's see how the decorator is used. So let's pick customers. So here's an example. This is the /customer/ route. We used to return here a Python dictionary that then was JSONified with our new JSON decorator. So what we're doing instead now is that we're saying that when we use this new paginate decorator, we return a database query. So note how simplified this is compared to the early versions that we had of this route. All we do now is return the query, and we let the paginate decorator handle that query and do the pagination for us. You remember that the JSON response for this route had a dictionary with a key customers. This is an argument that we are passing to our decorator. The decorator will be generic. It will be able to handle any collections. So we need to tell it how we want that collection to be represented in the response. Note that we haven't removed the JSON decorator from here. This is a nice way to chain decorators. If you have a sequence of decorators, then you can have them listed one after the other, and in this case, Paginate will be able to return a response that JSON can pick up. So Paginate can return a Python dictionary, and then JSON will take it and convert it to a JSON object. So let's take a look at the decorator now. So here we have the decorator. It has not one argument, it really has two arguments. The second one was default and I did not use it. So the first argument is the collection name. We are going to use this in the response. And we have a second option argument that provides the maximum size of a page. So let's see what the wrapped function does. So we start by invoking the wrapped function. So this will now return a database query. So we stored it in a query local variable. Now we are going to look at the options that we have for page. Here we need to specify what pages we want. So we are going to use the query string for that. So we have request.args. It's a dictionary that contains all the arguments in the query string. We are going to look for one named page. That's going to be defaulted to 1. So if we don't specify which page we want, we will go with page 1. And we are going to force that type to be an integer. So now we know which page we need to show. The next one is how many items per page we want. And here we are going to apply a little bit of logic. So as you saw above, we have a maximum per page. So this is the maximum that the server will provide. We will never return more than 25 per page by default, or whatever the route specifies in the decorator. But the client may want less than that. Maybe the client is a very limited platform and it wants to see, say, 5. So we are going to give the option to the client to specify how many it wants, and it will be capped at the maximum that we support on the server. So here we look for the the per page query string argument, and we default to our max per page. And when we get a value from this, we are going to compare it to our max per page, and we are going to use the minimum. So we will never allow the client to specify more than what we want to serve in a single page. So now that we have the page number and the items per page, we can use Flask SQL Alchemy's pagination function, and we run it on the query that we received from the route, and that will return pagination object. The pagination object will be used to generate the response, and the response will have two parts. In the first part, I'm going to have the list of links. So this is going to be the same as before, with the exception that now we are not going to show all the items. We are going to show just one page out of the item list. But then there's going to be a second section where we are going to provide the client with the information that it needs to navigate the remaining pages. So we are going to have an item called pages that's going to be also at the top level of the JSON object, and this item will have a number of items. We are going to have the page number and the per page item that we used to grab the page. We are going to provide the total number of items and the total number of pages that we have in this collection. Then we are going to add the links that the client will use to go at the different pages. So we have a previous URL, a next URL, and we are also going to provide a link for the first page and the last page. So all these are going to be URLs. So we use URL4 to generate them. Now these are URLs that point to the same resource that we are returning. So we can use the request object to get the endpoint that we need to use. So this is going to be always pointing to the same resource that we are handling right now. Then we can add the previous, in this case this is the previous URL, so we need to set up the query string with the previous page, and the per page needs to have the same number of elements. Since URL4, any optional arguments that URL4 finds in the argument list that do not match dynamic components of the URL, URL4 will put them in the query string. So this is how we get page and per page in the query string. And once again, we are going to use external URLs. So these are going to be fully qualified URLs. So this requires some explanation. Imagine that our URL4 is not the customer collection, which is a collection that doesn't have any dynamic components, but let's say it's the list of orders. So if you recall from the demonstration, when we get the list of orders for a customer, the URL has a dynamic component, the customer ID. So URL4 will need that ID to be able to generate the complete URL. So what we're doing is taking the arguments that were sent into the route. So these arguments are the ones that we called into the route, and we are repeating them when we invoke URL4 so that we get the same URL for the page links. So you can see here that I'm not always setting the previous and next page. I first check in the pagination object that Flask SQL Alchemy return if I have those pages, and if I don't, I set them to none. There's always a first and a last, so those two are always set, and here I use a hard-coded value for page, which is 1 for first and the total number of pages for last. So now that I have collected all this information, I need to generate a response that includes all of this information. So I use my collection argument. This is the argument that was given here to the decorator. This, in the case of the customers collection, it will be called customers. So that will be the key for the dictionary, and that will give me the get URL for all the items in my page. So this is p.items is the list of items in the page returned in the pagination object from Flask SQL Alchemy. And then I add the second element, which is the pages with all the metadata that will allow the client to navigate the pages. So I'm going to show you this in action in case just by me commenting on the code doesn't make it very clear. So I'm going to go ahead and start the application. So I'm going to create a new terminal here. And now I'm going to try to create a few customers so that we can see how the pagination works. So I'm going to activate my virtual environment, start Python console. I'm going to import my create app function and my database. Also, I need my customer model. There we go. So now I can create an application. And I'm going to pass the development configuration. Now I have an application. What I'm going to do now is create an application context and push it. So this will enable me to work in the console with my database. Now the database will know what the application that's active is and will go there to grab configurations such as the URL for the database. So let's see. Let's create, say, 100 customers. We are going to use a generic name that's based on the prefix plus the number. We are going to add this to the database session. And now that we have 100 customers in our session, we are going to go ahead and commit. So now we have 100. So we can exit this, and we have the API running on the other screen, so we can go ahead and try to query this. So recall that since now we're running in development mode, we can avoid sending authentication. We made a change when we created the full-blown application structure to allow development mode to not require authentication. We need to pass authentication, but it will not be verified. So I'm going to add here the authentication as an empty colon that will send an empty username and password. So I'm going to send a GET request to localhost 5000 API v1 customers, and let's see what we get. We get an error because I used the wrong URL. So this is the correct URL. So you can see here that we have received customers 1 through 25. This is in the customers list as before, but now we get a limited list. And here we have a second item in the JSON response that's called pages, and it includes a number of URLs. So we have the URL to the first page, one to the last page, and one to the next page. We also have one for the previous page, which in this case is null because we don't have a previous page. We are currently looking at page 1. So now I can go, let's say, to the last page. I can copy this URL and I can send empty authentication GET request to that URL. And here you can see that I get the last 25. So now let's say that I want just 10 items per page. So I add a query string argument where I say per page 10. So here you see I get only 10. And now my first and last and next are also configured to give me pages of 10 elements. So now we have nice pagination built, but if you remember from the very beginning, it may be inconvenient to some clients. I make a mention about this. It may be inconvenient for the client to receive just the links. So we are going to look at how we can improve that by using an extension to this Paginate decorator. So I'm going to close this session and stop the demo server, and now I'm going to check out version 13. So now I have added support in our Paginate decorator to expand our collections. And I waited this long because I did not want to have to deal with this in my routes. Remember that the goal of this section, where I'm showing you examples of decorators, is that you have very simple routes and that you move the complexity to other places in your application, in this case auxiliary decorators. So I didn't want to introduce this before because it would require making the routes more complex. But now that we have pagination that is implemented for all our collections, we can modify the Paginate decorator and allow this in a way that will be supported by a single code change. So let's see how that looks. So this is the improved Paginate decorator. We have, same as before, we get the query, the page, and the per page. Here we have an extra item that we support in the query string. I called it expanded. So if the client sends expanded set to 1, then we are going to return the collection expanded. If the client doesn't send the expanded in the query string, then we are going to return the links as we did before. So we save the value that we get. By default, we continue to go with the links, but if the client wants expanded, it sends the query string set to expanded equals 1. And near the end, you can see that when we generate the results, depending on the value of expanded, we either call export data on the items in our page, or we call item get URL as before. So you can see that with just this, we go from sending links to sending representations in the collection response. Also note that to preserve the expanded selection, I have added it to all the page links. So I want to return pages that are consistent with the initial request from the client. So this way, if the client requests expanded results, when it moves to the second page, continues to get the same thing. So let's give this a try. Now we have running. We still have the 100 customers that we created. So we can now go ahead and say get API v1 customers. We are going to say per page, and we're going to make it a short page, say 3, and we are going to add expanded equals 1. So now you see that when we invoke this request, instead we get the full expanded results in each entry of the customer's list. And we continue to get the pages. That works in the same way. You can see that here we are preserving the expanded equals 1 selection. If I remove the expanded, then this remains the same as before, and I continue to get links. So now we are giving the client the option to go one way or the other.